All right, so welcome everybody. This is the Evolution and Maintenance 2 session, which actually happens before Evolution and Maintenance 1, which is in 1 hour from now. I'm not Sigrid, I'm Max Dipenda, backup session chair in this session. So we are going to have 6 papers in this session, both journal first and technical papers. We start with the 5 minutes presentation for each paper and then question and discussion at the end. But in the meantime, feel free to write question in the chat if you want. Okay, so we start from the first paper, which is a journal first paper, and it's titled Maintenance Related Concern for Post-Deployed Ethereum Smart Contract Development, Issues, Techniques, and Future Challenges. Please.
Okay. Yeah, okay. Hello, Professor. Let me share my screen. Can you see that?
Yes.
Oh, okay. Let me start. Hello, everyone. My name is Jiaqi Chen. I'm an assistant professor in Sun Yat-sen University, and this paper related to smart contract maintenance is a journal first paper, which was accepted by INSEE last year when I was a PhD student in Monash University. There are 2 research questions in my paper. In first research question, we investigate what kinds of maintenance issues will a smart contract developer encounter. And in the second research question, we inform readers what are the current maintenance methods for smart contract. This is the overview of methodology we used in our paper, which consists of 2 phases. We first conduct a systematic literature review to find the preliminary answers of the research question, to find related literatures about smart contract maintenance. We use keywords to obtain about 1,000 smart contract related papers from 5 search engines. Then, based on 6 rules, we manually read the abstract of this paper and conduct a snowballing step to enlarge the paper list. Finally, we totally obtain 131 related papers. Then we carefully read all of these papers and use cut sorting to find the answers of the research question. Since smart contract is fast evolving, so some answers we found from previous literatures might out of date. Besides, there might be gaps between industry and academia. Thus, we also design a survey to validate our findings in phase 2. We totally received 165 responses, and based on their feedback, we finally obtain 13 maintenance issues and 4 kinds of maintenance methods to maintain smart contracts. For 3 maintenance issues we found, we divided them into 5 groups according to 4 kinds of maintenance type. And some kinds of maintenance challenge appear in all of the 4 kinds of maintenance. Thus, we divided these 3 maintenance issues into 5 groups. Due to the time limitation, I can't introduce them all, so I only give some examples. For example, in adaptive maintenance, we found our maintenance issues named unpredictable fork problems. This means in blockchain, we need a fork to upgrade smart contracts. However, some forks are unpredictable because when some attack happened, developers need to fork the blockchain to update the blockchain and fix the issues. However, this update is unpredictable and makes the maintenance very hard for smart contracts. Let's come to research question 2. We totally found 41 papers introduce methods to maintain smart contracts. 31 of them are offline checking methods. This kind of method usually checks smart contract defects before redeploying smart contracts by using program analysis method. Online checking method is able to maintain deployed smart contracts without redeployment, but most of them cannot be used directly currently. For example, one kind of online checking method is batch code rewriting. The tool will check whether a smart contract contains related defects or bugs and then rewrite the batch code. However, these kinds of methods cannot be used now because these tools need to be merged into Ethereum virtual machine. However, due to the high positive of these tools, and they need to be modified the batch code, which obeys the immutability features of blockchain. So they are impossible to be merged into EVM in recent few years. Thus, the most popular method to maintain smart contract is offline checking method, like static analysis, fuzzing, formal verification, and so on. Thank you for your listening. My talk is finished.
Thanks a lot. So feel free to start asking questions on the chat. But in the meantime, we move to the second paper, which is also a journal first paper, and is titled Context-Aware Retrieval-Based Deep Commit Message Generation. Is any of the authors here? Any of the authors of the second paper? I wait a couple of seconds, and then in the interest of the time, we shift to the next paper. No? Okay. All right, so the second paper is not here. We move to the third paper then, which is a technical track paper and is titled Recommending Good First Issues in GitHub Open Source System Projects. Please. Not sure we can hear you. Maybe you're muted. Yeah, you're muted. Should just open the mic.
Oh, no, okay.
Yeah, we can now. We can hear you, but you should share the screen again. Yes.
Yes.
Thank
Sorry.
You. Okay.
Okay.
Great.
Okay.
Perfect.
Okay, I'll start. Hello, everyone. I'm Wenqing Xiao, a PhD student from Peking University. Today, I'm going to introduce our work about recommending good first issues in GitHub OSS projects. Nowadays, open source software has become quite important in our society. If upstream repositories are poorly maintained, projects using them may face potential risks. For example, bugs will not be resolved. One major challenge of OSS sustainability is to attract and retain capable newcomers. A good influx of new developers can resist the crisis of project sustainability caused by the loss of developers. GitHub officially recommends projects to use the good first issue label to tag issues that may be suitable for newcomers. The newbies who are searching for potential suitable issues can choose a project and look through issues with GFI labels to find one to contribute. However, according to previous work, the GFI mechanism have faced some challenges. The first is that GFI label is rarely used. The second is that only very few issues marked as GFI are rarely solved by newcomers. To solve these problems, we propose an automated approach to recommend the GFI. It can reduce the burden of manual labeling and the false labels due to misjudgment of labelers. The goal of this work is to identify issues in a project's open issues that may be suitable for newcomers. Instead of using GFI label to set the ground truth, we regard issues solved by newcomers are suitable for them. Besides, the developers made no more than K commits for a project is a newcomer for the project. We collect data from 3 sources. Content include issue title, body, and labels. Background include reporter and project-related data. And the dynamics of issues include data from discussions and events. Then we use XGBoost to train our model because it outperforms other models. We use GHTorrent and GitHub API to collect data. We identify the top 100 repositories with the most GFI signaling label. We only collect issue closed by pull requests or commits. We collect data at 2 time points, when the issue is just reported and before it is assigned. In RQ1, we examine the model performance. Table 1 shows the performance under different thresholds. The model achieves more than 0.8 AUC for the second time point. Figure 2 shows our model distinguishes issues well. Then we compare our model with the baselines and the variance of our model. Our model achieves best performance with XG. The reporter-related features seem to be the most important indicators. In RQ2, we find that issues reported by a developer with just enough experience, document type issues, and issues involved with experienced developers are more likely to be solved by newcomers. In RQ3, we check if our method is helpful in a real-world setting. We report potential good first issues, and 16 issues are confirmed as suitable for newcomers. Here are some feedbacks for our reports. Developers are positive about automatically recommended GFI. Here we show our contributions. First, we formulate and define the GFI recommendation problem. Second, we analyze the features of GFI. Third, we propose a tool to recommend GFI and verify its good performance. At last, we provide a public GitHub issue dataset. You can find our artifact at the GitHub link. Thank you for listening my presentation.
Thanks a lot.
Thank you.
Okay, so we move to the next paper, which is about guideline for assessing the accuracy of log message template identification techniques.
Hello, I hope you can hear and see. So my name is Zainis Ali, and we are going to present the paper guidelines for assessing the accuracy of log message template identification techniques. The other authors include, as you see here, Dongwan Shin, Domenico Biancoli, and Lionel C. Bryan. Now, if we see that the software logs are actually everywhere in any system, in computer system, mobile system, and so on, and they are the only data available that reflect the system behavior and are used for various software engineering tasks such as anomaly detection, model inference, or testing. Now, the thing is that for log-based analysis, we need to have a structured log that is extracted from the free-form log messages. But how we can get the structured log? There comes the process of template identification that takes as input the set of log messages or log message, and it converts it into event template that is fixed tokens or the variable tokens. Now, most of the time we do not have the source code in hand. Otherwise, it would be easy to extract the template, of course, manually. Here in the literature, here are 14 techniques that we already saw or that we already used in our paper. So the problem that comes is how one can assess the effectiveness of template identification techniques. There comes the goal of our paper, that is to provide guidelines to assess template identification techniques based on the targeted or intended use case. Now, the scope of our guideline include these 3 points that we will see in details in the further slides. Now, if we look at the accuracy metrics that are used in the literature, we have two accuracy, that is grouping accuracy and parsing accuracy. Now, the drawback of those accuracy metrics are that both are sensitive to the number of log messages, and this is problematic if log messages are repeated, for example, heartbeat messages. In order to mitigate that issue, we propose a new metric called as template accuracy. What it does is it considers correctly identified templates rather than the correctly parsed messages as GARPA does. Now, the issue that we observe based on the literature review is first is that results from different accuracy metrics are not properly compared. In order to provide the guideline, one should use a metric that adequately assesses the accuracy of template identification in the context of the targeted use case. And the two important criteria that should be kept in mind is that variable tokens are required or not, and the second is message frequency is important or rather not. So the second issue that we observed is that Oracle templates are the base and are not always correct, mainly when extracted manually without access to the source code. As we can see, we don't have source code most of the time. So for example, if we see we have a log message status is false. Now one can extract a template status is false, but as we know that the Boolean that is true or false should be kept or is kept mostly as a variable token in the log print statement. So the correct Oracle would be status is static instead of status is false. Now, for that, we can say that one should use Oracle template correction, as the Oracle templates extracted without using quotes are most likely incorrect. And here are the rules, few of the heuristic rules that are based on the manual investigation of Oracle templates in LogHub, that is open source, publicly available log benchmark. So if we see here that let's say the second example, we have a digit. So one should replace, or the rule should replace digit token with a variable token. As you can see, the digits are mostly not a fixed token in the print statement. So here EUID 0 should be kept as a variable token. Now the third issue is that additional information about the incorrectly identified template is not available, and it would be great to have that information in hand. So the third guideline for that is to understand in which way templates are incorrectly identified. We propose analysis of incorrect templates. So the basic idea is actually to consider template identification as a process of generalization. So for example, if we have two messages that is retry 1 and retry 2, those two can be generalized as a single template that is retry static variable or static. Now our analysis classify incorrect template based on the level of generalization as we discussed about, that is overgeneralization, undergeneralization, and the mixed. Now, we would like to go to evaluation section. We have 3 research questions. That is, how does the ranking of technique vary when using different accuracy metrics? And the impact of Oracle template correction on different accuracy metrics, as well as the analysis of incorrect templates provide any insight to improve template identification techniques. And we will see the results in the next slides. Now, how does the ranking of techniques vary is that the ranking of techniques vary a lot depending on the choice of accuracy metrics, as it should be based on the intended use case. And it is essential to use an appropriate accuracy metric according to its use case. Should not be rather a random choice. So what of Oracle template correction is that the Oracle template correction is important for properly ranking template identification techniques based on their accuracy, as well as on average, we saw that 28.5% of all Oracle templates were incorrect and therefore corrected by our heuristic rules that partially presented in the previous slides. Now, the last research question for that, we would say that, is there any insight from the analysis of incorrect templates? Then we can see that, yes, different techniques have different percentage of overgeneralized, undergeneralized, as well as mixed type. So based on the results, the weakness of different template identification techniques can be easily identified and thus possibly can be improved. So with that, I will wrap up the presentation. Thank you for your time.
Thanks a lot.
Thank you.
All right. So next paper, which is about automated patching for unreproducible editor for the yes. Okay.
Dalian University of Technology. It's a great honor to present our work. So this study is about reproducible builds. A software build is reproducible if given the same source code, build environment, and instructions. Any user can generate bit-by-bit identical artifacts. Due to its wide applications, such as to safety, debugging, and delivery, various repositories have been conducting their validation, such as Debian, Guix, Arch Linux. The validation workflow is as follows. It's generally build the source for multiple times and comparing the artifacts. The validation could be conducted automatically, but unfortunately, the fixing is mainly manually conducted. Towards the automated fixing for these issues, we have identified two major challenges, the localization granularity challenge and the historical knowledge utilization challenge. To tackle these challenges, we propose a novel approach for automatically generating patches for these issues. The solution features a system-level tracing monitor to gain the mapping between the build commands with their locations and leveraging cumulated patches for fixing issues of new packages. By combining the two mechanisms, we are able to generate patches for validation. So here we present the framework RevFix. So there are two major components in RevFix, the tracing-based fine-grained localization and history-based patch generation. We start with the normal build process. To capture more verbose information, such as system call and function calls, we use a trace monitor, which loads a tracing script, compiles it into a kernel module, which further attaches probes to both the kernel and user space. When we start our build process, we can obtain not only the artifacts, but also the build trace. With this as input, we can conduct the localization and obtain the accurate location of the commands for patching. Then we proceed to the patch generation. On one hand, we extract the command for patching with the command extraction module. Also, with the command, we retrieve the most similar patch from the bug tracking system of Debian. And we construct a template from the existing patches and apply the edit operations of the templates towards the command for patching and get the patch command with which we can generate a candidate patch. Then we use this patch for validation to obtain the final results. In the validation process, we consider the following criteria. First, no artifacts are missing. And second, the patch source could generate bit-by-bit identical artifacts. Also, we have to conduct manual check for the final results in that there might be a malformed patch which generate false positive. For the third part, we present the experimental results. Extensive experiments are conducted over real-world packages to evaluate the effectiveness, the contributions of each component, and the efficiency of RevFix. Also, we conduct a case study to examine whether RevFix could be extended to other repositories. Due to time limit, I will not introduce this in depth. Finally, the conclusion. To the best of our knowledge, this is the first study to generate patches for unreproducible builds. We developed RevFix, which features a tracing-based localization and history-based patch generation. Extensive experiments are conducted to demonstrate the usefulness of RevFix. And for future directions, we're interested in generating fixing rules from the existing patches. Also, we're interested in extending these techniques to new repositories and new platforms. And thank you. That's all.
Thanks a lot. All right. And we move to the last but not least paper in this session, which is again a technical track paper titled Using Pre-trained Models to Boost Code Review Automation, and this is going to be presented by Rosalia Tufano.
Thank you. Okay, I hope you can see my screen and the slides. Okay,
Yeah.
so Hello everyone, thank you. My name is Rosalia Tufano and I'm a PhD student at Università della Svizzera Italiana in Lugano. So today I'm gonna talk you about the work using pre-trained models to boost code review automation, built on top on our previous work towards automating code review activities, presented at ICSI 2021. In which, in order to reduce the human effort in the code review process, we made a first step to automate some of its related tasks. Now we can summarize the code review process in the following way. There is a contributor who is the developer writing the code and submitting it for review. The code is reviewed by one or more reviewers who can recommend code changes in natural language. And then the contributor revises the code implementing those changes and create a new version of the submitted code. And so this process can be iterated several times until the reviewer is happy with the implemented changes. So we defined two tasks. The first one is the code-to-code task, in which, given the submitted code, we want to automatically generate the revised code. The second one is the code and comment to code task, in which, given the submitted code and the natural language comment of the reviewer, we want to automatically generate the revised code implementing the code changes suggested in the comment. So we trained the two transformer models, one for each task, using a dataset that we collected from real code review activities, obtaining for the first task from 3 up to 16% of correct predictions, depending on how many attempts the model is allowed to make, and 12 up to 31% of correct predictions for the second task. Now, these results were promising, but our approach had some limitation, in particular in the dataset that was not really representative of a real scenario. This was due to the fact that to simplify the learning, we applied some filters. One of the filters that had an important impact on the dataset was the one on the length of the method that we fixed at 100 tokens. So all the methods consisting of more tokens were removed from the dataset. Moreover, to reduce the vocabulary size, we didn't work with raw source code, but with an abstracted version of it, in which all the identifiers and literals are replaced with the specific numbered identifiers, as shown in the example. Now, the problem with the abstraction is that if in the revised method a new variable is introduced, we are not able to go back to the raw source code, and so we removed the dataset all these cases. So in the current work, we try to overcome these limitations. So first, we dropped the abstraction process and adopted the byte pair encoding. Now the goal is to capture subtokens that we can use to construct a completely different sentence. So the vocabulary is built with subtokens instead of entire tokens. And in this way, we can work with the raw source code. And at the same time, we are still able to take under control the vocabulary size. Next, we relaxed the max length filter. This time, we allow to have in the dataset inputs that have up to 512 tokens. Finally, we also collected new data from open source project, and summing up everything, in this way, we go from having a dataset consisting of 17,000 instances to have 167,000 instances. And the dataset increased not only in the size, but also in the complexity. So to handle the new dataset dimension and complexity, we need a more powerful model. So we leave the classic transformer model and adopt the text-to-text transfer transformer, or simply T5, that can be seen as a sort of evolution of the transformer. So we started the evaluation of the new approach comparing T5 with the ICSI21 model on the ICSI21 model. Dataset. So here we have the results. In this graph, we can see on the horizontal axis the beam size, and that is the number of predictions the model is allowed to make for a given input. And on the vertical side, instead, we have the percentage of correct predictions. So we can see in particular generates one single prediction, we have 3 times the chance of getting the correct one. Finally, to evaluate T5, we evaluate T5 on the new, bigger and more complex dataset. And these are the results. We can notice that in this case, the performance of T5 on the new dataset are lower compared to the performance obtained in the old dataset, XC21 dataset. But this was something that we expected because, as I said before, in the new dataset, we have more complex code changes. So this concludes my presentation, and thank you for your time.
Thanks a lot. Okay, so at this point we are done with the presentations, and the floor is open for questions. So I would like to start from a question from Gabriele to Wenxin. So the question is, you label an issue as appropriate for a newcomer if it has been solved by a newcomer, where a newcomer is someone who performed less than K contribution in a project. Does the fact that the issue has been solved by a newcomer make it appropriate for all newcomers? Because there may be some newcomer that never contributed to any open source project, while others are very experienced in other open source projects, but this will be the first contribution in that particular system. So basically the question is about, there are different kinds of newcomers that already have a previous open source experience, but are newcomer in the project, and newcomer that are really at their first experience.
Yeah, thanks for the question. Actually, there is no clear definition for what kind of issues are suitable for newcomers. GFI label is not a clear label to show if the solvers should have development experiments. In this work, we do not divide newcomers into experienced developers and open source newbies. We just recommend potential GFI with our approach. Project maintainers and issue reporters can decide whether to add such a label to the issue by themselves. And other labels such as issue types like bugs, like other labels can use as additional labels to tell the newcomers what kind of issue this issue is. And the newcomer can find the issue with these labels, and they can see the detail of these issues to decide which one they can do and contribute. So and we will divide newcomers into development newbies as our future work. This is a very good question. Thank you.
Thanks a lot. Just a follow up,
Max.
Yes,
Max, maybe I can just follow up on the answer. Thanks a lot for that. I had this question because in the past we studied, for example, the Apache ecosystem, and there are many projects that are managed by the Apache Software Foundation, and there is a lot of overlap of developers between these different projects. So maybe you have a developer who is newcomer in a given project, but he already contributed to several other projects of the Apache Software Foundation. So for that person, probably it's easier to contribute as compared to other newcomers who performed their first contribution in the Apache ecosystem. So I think it's a good future direction, but thanks for the answer.
Yes, thank you.
Thank you. Yeah, I wanted to follow up with another question to the same speaker. Did you try to contact a developer to establish a better ground truth? Or what about doing also that? Because I remember in the past we did a study about newcomers, and we realized that the best way to assess our results was actually to contact people to understand whether the assignment was appropriate or not.
So sorry, can you repeat it?
Yes, my question is whether you tried to contact developers to establish a ground truth.
Yeah, we contact. We report some good first issues to the projects and contact with some developers. They are very interesting with recommending GFI, and we will contact with them later after this work is published.
Okay, I see. Thank you. Okay. Okay, I'll ask another question, then I will go to the next question from Gabriele. So this time a question from Rosalia. So it's great that you are continuously improving your approach towards across the different X's, maybe going to do yet another better one. So from what I understand, of course, your approach generated code review for a specific method, but sometimes code reviewers assess some characteristics of the program that are somewhat cross-cutting, like you are not commenting your code properly, or you are not using the proper code style, and similar things. So those characteristics are learned maybe from the entire page. So I understand, of course, that your work is not in scope to what I asked, but how do you see in future the possibility of automatizing also this kind of code review?
Okay, so thank you for your question. So for now, we removed from the dataset all the cases in which, for example, the comment is about another comment in the method, or about I don't know, spaces, this kind of things.
General.
Yes, but we still have some comments related to the style, you know, parentheses, this kind of stuff. So for now, we can handle different code changes, but actually we don't have future for this stylish, let's say, review. So for now, no, but yeah, this is something that we can do. Yeah, for sure. We can support also in this way. Yeah.
Okay, then Gabriele has a question for Zanis. Can you better clarify what is an appropriate accuracy metric for a specific usage scenario?
Hi, yes. So it's a nice question. So basically, if I go towards the presentation, then if you remember correctly, we had two important criteria to select a better metric or appropriate metric. So the basic two criteria were, are the variable tokens required or not? And the second was, if you remember, that the importance of log messages important, or the frequency is important or not. So the simplest example would be, for example, if we want to see that a model that is log key anomaly detection model of deep log that is presented in CCS 2017. So what it does, it aims to detect behavior anomalies using the system event sequences recorded in the log. So it does not actually much care about the message itself, but it cares about the sequence ID or the template ID. So it uses log template identification to convert those sequence of log messages to a sequence of log keys, or in other words, you can say event IDs. So the GA metric here would be the appropriate to consider for this model. On the other hand, if the parameter values are required, then the GA is not the metric that should be appropriate, because GA does not care that the messages are correctly parsed exactly or not. It does not care parameter values are exactly as it should be or not. So for this simplest example, I would say that here GA would be appropriate for behavior anomalies that deep log does. But on the other hand, it does have another model that use actually parametric irregular parameter values. For that, you cannot use GA. So for that is not an appropriate metric. So basically, two different models trying to figure out two different anomalies. So there should be two different or separate, you can say, metrics that should be utilized. Or in other words, that should be the appropriate metric for those two different use cases. So I think that answered my question. Thank you.
Okay, thanks a lot. So more questions from the audience? No? Okay. So I have a question for the first speaker about the maintenance-related concern for the smart contracts. And yes, I'm interested on better understanding how did you move from the systematic literature review to the validation with the developers? So what kind of question did you ask and how you create the question?
You mean what question I ask for developer?
Yes, and how did you identify those questions?
Yeah. Actually, I have two research questions, and this is what I want to answer in my paper. And I first found the answer of these two research questions from some previous papers. But I think because blockchain technology is fast evolving, and some answers from the previous paper might out of date. So I need to prove the answer I found from the papers. So I send this answer to the developers and ask them whether they agree this answer is true or not. And this is the survey I sent for the developer.
Okay, thank you. More questions? Come on. Otherwise, I will try to ask a few more. So
I have one, Max, if you want.
Yes.
I don't write it. It's easier if I just
yes,
ask.
please.
It's for Wenshin. I was thinking, you have I think for your work where you say that open source projects tend to not use this label to explicitly tag these first good issues. But I was thinking, I'm not sure if you did that or not, but I understand that for the training data set, you need a lot of data. So you came up with this heuristic where you say, if it has been solved by a newcomer, it's good for a newcomer. But did you use the same heuristic also for the test data set, or for the test data set, it could make sense to use the issues that have been manually labeled by the open source projects?
Actually, we didn't use GFI labels as to set the ground truth for our data set because we previous work find that the label are always wrongly labeled. So we actually didn't use it. Instead of it, we just use issues resolved by newcomers or non-newcomers for the whole data set. We just find the issues closed by commit or pull request. Then we can find the resolver of the issue, and we check if the resolver have committed more than k commits. If they didn't commit such commits, they are newcomers, and if they commit more than k, they are non-newcomers. For the training data set, is like this, and test set is also like this. We just sort the whole data set by time. We use the same ground truth for the whole data set. Yeah.
I see. Okay, so the motivation is that basically those labels are not reliable. This is why you didn't use them in the test.
Yes, the previous work find that only 14 or maybe less percent of them are really resolved by newcomers.
Okay, so in theory, you can also experiment your approach to see if you can fix those wrong labels, right? Maybe you can recommend to the projects, look, these labels should not be there because this is not a good first issue for newcomer.
Yes.
Okay, sounds good. Thanks a lot.
Thank you.
Thank you. More questions? Okay, think about it. In the meantime, I'm going to ask a question for the unreproducible builds paper. So my question is more general. What are the main reasons you found, at least in your data set, for unreproducible builds? And what, in your opinion, are the more difficult to be patched?
Thank you for your questions. In our research, we found the most frequently observed reason for the unreproducible builds lies in the timestamps. For example, the output of a date command embedded in the file, timestamp in the header of a compressed file. For example, if you compress a file with gzip, by default, there will be a timestamp embedded in the header of the compressed file. So when you compress a file at different time, normally you will get different files, and with different files, they are identified as inconsistent artifacts. So the build will be as unreproducible builds. For the difficulty, I think it's very challenging to deal with different, say, build systems. In our study, we consider two types of build systems: the GNU-Make and Bash. And due to the different grammar, GNU-Make even does not have a formal grammar, so it will be challenging to generate say valid patch that could be successfully compiled. I think that is a challenge, a technical challenge. Thank you.
Thank you. Yes, actually, your answer confirmed my second question that I was going to ask, and then also a follow-up question. So my other question, I was curious about whether one of the causes could have been flaky builds or flaky tests, and indeed, in some way, what you mentioned before is a reason for flakiness. So I'm wondering whether, at least for those kind of problem, the problem can be detected and solved with approaches aimed at coping with flakiness. Although, of course, this is not the kind of flakiness that you can repair with multiple retrial, because, as you said, it's a timestamp. But so basically, it's also a problem of flaky build, correct?
Yeah, I totally agree. Actually, during discussion with other researchers, some may suggest if you should name it a flaky build. It's closely related to flaky test. Yeah,
in a way or the other, in the sense that there is a specific kind of flaky build. Some flaky build you can repair by retrying, but since here it looks like there is a check of a timestamp, you can do as many retrials you want, and in that way you will not fix the flakiness. The other thing you mentioned, Make and Bash. How will the approach work with other modern build automation like Maven or Gradle?
We didn't try other build system. I think if we would like to extend it to other build system, we have to capture the mapping relationship between the build command location and the actual build command. For most build system, it's natural for this system to maintain such relationship. So I think it should be straightforward to port this technique to other build systems. Yeah.
Okay. Thank you.
Thank you.
Okay. Maybe I have a final curiosity for Rosalia, is whether your approach was able to generate any code review that was related to some non-functional properties, like this code is not well optimized or something like that.
Thank you for your question. Okay, I'm not sure about that. In the first paper, we built a taxonomy of the code changes that the models were able to solve, let's say. But I'm not sure we have this kind of code changes that we can solve. So you are talking about something like performance or, I don't know, security optimization of the code.
Yeah, of course, performance that does not require execution, because otherwise it will be clearly impossible. But when a code reviewer realizes that a piece of code like a loop is written in a non-optimal way and suggests to reshape the loop.
Okay. No, yes. In this case, we have some. So yes, we have some refactoring operation that the model is able to assess. Yes.
Okay. Thank you very much.
Thank you.
Further questions for the authors? No? Okay, so if not, since we had one paper less in this session, I would like to thank again all the speakers and close down the session now. Thanks a lot and congratulations. Great work.
Thank you. Bye.
Bye.